Hi, everyone. Today we are going to be talking about the centralized commercial consent database for 80 million citizens across more than 100,000 companies and how we implemented distributed data and microservices together with YugabyteDB. Today, I will be talking about what we are doing at Softtech. My colleague Cetin will be talking about the today and the tomorrow of the use case. And my colleague Shivam will be explaining how we implemented the solution and what was our motto about the modern problems require modern solutions. My name is Cem Aladogan. I am the product manager of Data Plateau at Softtech. Data Plateau is a streaming data analytics platform where we try to build the easiest and fastest way of collaborating on data for our clients. Softtech is a leading technology company based in Turkey, and we have offices in Istanbul, Ankara, Eskişehir, San Francisco, Frankfurt, China, and North Cyprus. Today, we are almost 1,500 people working at Softtech, and we are mainly focused on banking, finance, and capital market sector. Softtech operates since 2006, and it has been almost 15 years right now. And we are operating in different kinds of sectors such as retail, health and medical, insurance, agriculture, logistics, and mobile. We have three main legs at Softtech that we focus on. The first one is the products where we implement treasury, capital markets, financial and banking solutions mostly. The second one is the innovation where we have two regions. The first one is to implement solutions within the Softtech itself, where we have an innovation funnel. We find out the best ideas within the Softtech. We try to implement them. And if they're successful, they have the opportunity to spin off from Softtech as a subsidiary, and they can be managing their own company. They can be going after their own ideas. And the second one is that we support the startup ecosystem within Turkey. We state ourselves as the CTO or CIO or the implementation partner of the startup. And we help them to build the technology, build the digitalization of their idea. And the third leg is the professional services, where we try to implement the best solutions inside the market with the best partners for our clients, such as business process automation. We are working with the Pega Systems. Enterprise service management, we are working with the ServiceNow. From the robotic process automation perspective, we are working with the UiPath. Aside Data Plateau, what we do is to build the data-driven agile architectures. We mainly focus on how we can process data from one source to another one, how fast it can be, how useful it can be, and how we can solve the business problems, real business problems with the data-driven approaches. According to that, we have a huge partner ecosystem. We have a huge open source ecosystem where Shivam is going to explain to implement agile data-driven architectures. So I'm leaving word to my colleague Cetin Yalcin to talk about today and tomorrow of the use case. Thank you very much.
Hello everyone, my name is Cetin Yalcin. I'm head of analytics at Softtech Turkey and product owner for this project. Today, I'm going to talking about today and tomorrow use case of this consent database project. This project is creation a database which provides the management of more than 80 million receivers consents for commercial and SMS messages from more than 100,000 companies. All service providers, which means is all companies in Turkey, provide register receivers electronic consents in scalable system. And that means 1 million write and 5 million read in a minute. Service providers are responsible to keep the database up to date. And intermediary service provider have to check the database read-only if receiver has authorized the provider to send commercial information for short message or email. Intermediary service provider will read the information from microservices located in their data centers. They need to read data as fast as their transactional systems. All the personal information must be encrypted and stored in the central database because GDPR restrictions. Central consent database with 5 different partners in Turkey. One is service provider. All individuals and legal entities sending commercial electronic messages. The responsibility of service provider is to ensure compliance with the legislation. Process must be easy and secure management of consents. Another partner of this system is the recipients. It is either a consumer or an individual on behalf of a business. Recipients manage all their consents via an account and easily change the status of their consents. Of course, these systems include public authorities. There should be more efficient and effectively compliant management systems. Another partner of this system is the intermediary service providers, such as GSM operators. The firm which is obligated to screen the status of the consent before allowing the messages or email to be directed to the recipients. And the last partner of this system is solution partners. These providers for aim to integration to system, solution partners provide integration services for their customers to reach and consume services. And we have 3 main requirements, business requirements for the system. Information will be distributed to 5 data centers because service providers such as GSM operators want their services running on their data centers. And then 5 data centers will run the system same time. And second metrics is the system must be available to encrypt and write in a minute 1 million records. And the system must be able to read and decrypt at least 5 million in 1 minute. Okay, now Shivam explain our technical solution.
Thanks, Cetin. Hi, hello all. This is Shivam Arora. I'm a product architect of the Plateau at Softtech, and also doing consulting on data-driven projects such as this. As Cetin described the business requirement, so we have highlighted a few of the technical points here, which are system should be highly consistent and scalable, as well as hybrid. Sorry for my cat interpret. System should be highly throughput with high throughput and low latency. It should be deployable to multiple data centers. System should also be able to query on of approximately 30 terabyte of data. For a specific use case, it should be deployable to our partners' data centers as well. And last but not least, our emphasis was on using open source technologies as much as possible. For the technical requirement we have in our hand, we adopted a CQRS model, command query segregation. So for the query part of it, we are using Elasticsearch because we have a requirement of full text search. For the command side of it, like the right side of it, we have done POC on a few of the database we have, like MongoDB, Cassandra, and YugabyteDB. With our small POC, we have found some differences or which has worked for us or not, such as like MongoDB does not have auto sharding, distributed transition not supported on sharded tables, whereas on the Yugabyte side, it is by default auto sharded. Transition is always supported on the sharded tablets. MongoDB is an asynchronous replication between primary and replica, whereas Yugabyte has graph-based synchronous replication, which is very important for consistency. Coming to the Cassandra side of it, Cassandra is a eventual consistent database, which is kind of does not fit to our requirement. And our previous experiences, we have seen Cassandra has issues with when you scale out to a very high numbers. Whereas on the Yugabyte side, it's strongly consistent and highly scalable. And the Cassandra side has a secondary index performance issues, whereas the Yugabyte, so far we have seen very minimum performance impact when using secondary indexes.
So here you can see our simplified architecture for this project. As you can see, that there's a clear demarcation between stateless and stateful applications. So stateless applications are running on Kubernetes cluster for auto scaling and high availability purpose, and as well the stateful applications such as Postgres, Elasticsearch, and Yugabyte, they are running on standalone VMs. It's a totally event-driven architecture for high availability and high scalability. So the request comes in through API, and then they just drop the message on the message broker, which is Apache Pulsar in our case, and the agents which are running a specific business use case. So they consume message and they apply their business logic and persist data to a Yugabyte, and for the query purpose they persist data to Elasticsearch, and then they produce message for the next agent, which my friend Cetin described. Like we have different business requirements like recipients and consent and operators. Our system is end-to-end monitored by using Grafana and Prometheus. Also, Keycloak is we have used for authentication and authorization purpose. With this current architecture, as it's totally distributed, it's very easy on the development part of it, because you can easily onboard a developer, since it's a micro agent. So anybody at any point of time can just pitch in and start doing development without knowing the whole business. In the next slide, I'll just go through the typical API request flow we have. So we have an API which I shown you in the last slide. We have a sync request and async request, but internally we process both the request asynchronously. So API receive message and it just produce the message to a topic, and it immediately reply back with the response ID in case of async request, and then it writes to Elasticsearch for the later on if for the request response. Then it pass on to the encryption agent, and it encrypts data using we use HSM for it. And then once the message is encrypted, it pass on to the consent database, which is our primary database for storing all the consents. So once a database is persisted to the Yugabyte, then we write the same message to Elasticsearch for querying purposes, which is served by UIs. And then next we have a consent history. Like for every consent we received, so we are also like writing the history of it, and then such on. In the number 9 agent, it does some of the decrypt process, because for some business requirements such as operator use case or recipient, there are some data needs to be decrypted and stored for querying purposes. For one of the use cases, my friend Cetin described the operator. Since all the GSM operators, they have a very low latency requirement, so we decide they wanted to have the data very in their own data centers. So what we did is with the help of Yugabyte asynchronous replication, we just replicate a single table to different data centers and deploy our APIs to their data center so they can do local read, and by this they avoid the network latency, and they with this we provided them the low latency. We have typically 500 million transactions per day, which is replicated to the different DCs, GSM operators DC, and it has possibility to further expand to different data centers as well. Here are some numbers we are currently have in our system. There are 500 million transactions, as I said before. So far, we have 5 billion consents registered. Among 5 billion consents, there are 110 million unique phone numbers, 150 million unique emails. Recently, we have opened our system to all the citizens in Turkey. So they log into the government portal and they can change or they can manage their own consents. So we have seen so far 1 million visitor, and during the peak time we have 10 million transaction. This is the technology stack we have used so far. As you can see, it's a very broad technology stack we are using. Thank you.